SAT Math DESMOS Mastery number 3. Are you ready? Let's go. So previously we saw one constant. So can we deal with two constants in DESMOS? Let's see if it's possible, and then you can let me know in the comments below what you think. Okay, in the given equation, S and R are constants, and S is greater than 0. If the equation has infinitely many solutions, what is the value of S? So remember, in this case, the graphs have to be superimposed on each other. They're not parallel. They're not doing intersecting. They have to be literally the same graph. Okay, so what I'm going to do is I basically have written the graphs here. So the first one is 12x plus 28 divided by 4 minus s by 13. That's our first graph, and there's a slider appeared, say add slider s. And then the second graph, I put it on a second line because this is a system of equations. Okay, so r x minus a I put on second line, and then r slider has appeared. Okay, so let's go ahead and click on the S slider, and here we have a graph right there. Okay, all right, very good. Now if I click on the R slider, what's going to happen is we get another graph. Now I'm going to start moving the R slider so it looks more or less parallel to the S slider. Okay, that is very zoomed out. So what we are going to do is we are going to zoom in here. So there, that's better. So okay, so now we are zoomed in closer out here. Now if you see, that looks more or less parallel, but now we have to superimpose them together. So I'm going to start moving the S one, and we need to find the S value anyways. So start moving the S. I moved it all the way to 10. Nothing seemed to have happened. Well, I may have to increase the bounds out here. So I'm just going to make it very large because it seems like it might be a large number because it's not moving very much. So I'm just going to go ahead and do this. And then now I can see that it's actually moving. See, the larger numbers are coming through and it's moving. So the goal is to superimpose these two together and see what our answer might be. Okay, now the trick here is to make sure they're actually superimposing. So if you go zoom in closer, you see in order for them to superimpose, we still have to move the slider a little bit more. So slowly, I'm going to try to, okay, move this. Okay, that went too far. Okay, so looks like 403 is where the lines are superimposing. So we would say the answer is 403. But you have to be careful. If you get a multiple choice, that is a very likely better way to solve this kind of problem. If you don't get a multiple choice, and you want to be 100% sure of your answer, you may have to do it algebraically, okay? And I'll show you next time. Let's leave me your comments below, and I'll show you next time how to do that algebraically, all right? All right, have a wonderful day. Bye.